Welcome to TechX Demo Day 2022. A very, very warm welcome to you all. It's a great pleasure to see you here, whether you're here in front of me in our fantastic hub in Aberdeen, or whether you're joining us online from across the world. It's fantastic to see you here today. And I think we've got a fantastically exciting day ahead of us, and we're going to be hearing from some wonderful startups. Next slide, please. So today is all about 12 game-changing pioneers, startups. And these startups all have clean energy technologies. Yes, this is the first TechX cohort to be fully dedicated to clean energy technologies. And these companies really do have an exciting prospect to help us accelerate the transition to a net zero future. And they will all, in future, we hope, be saving the world millions of tons of CO2 emissions. And forecasts suggest that that will happen quite soon. So by the end of the decade, in aggregate, we're expecting these startups to be saving several millions of tons of greenhouse gas emissions. So really, really exciting. These startups really do have the chance to make a big, big impact in the world. So where are they from? Well, they're pretty diverse, actually. So we have 3 from Scotland, we have 3 from England, and then the remaining 6 are international, spread across the world. And diversity doesn't just end there. We have 5 out of the 12, 42% are co-led or led by females. And that is really fantastic, especially in the clean energy industry. So we're absolutely delighted by that. And of course, diversity breeds success. And so that diversity increases the chance that these startups will be hugely successful in future, which is, of course, all that we want. Next slide, please. So how did they get here today? Well, it wouldn't surprise you to know that it's been pretty competitive. So we've had more than 230 applications. And those applicants were assessed by over 70 expert assessors, all experts in their field, in a pretty intense assessment week at the end of last year. And then the top 14 pitched live to a panel of 8 judges. And from those 14, we took the 12 pioneers on the cohort that started 15 weeks ago and ends today. Next slide, please. So these startups have been through an extremely intense program, but they've already been delivering. So they've already, in these last 15 weeks, they've already raised £4.2 million of equity, and there's another million being discussed. They've started 11 field trials with customers, and 3 have been concluded, and another 7 leads are being pursued. So really impressive performance already, and this is just the end of week 15. So I think we know that great things are coming from these pioneers. Next slide, please. So what's going to happen today? Well, you're going to be hearing from each of these 12 startups. They will each be pitching to you for 5 minutes. Some will be here in Aberdeen in the hub, others will be joining online. And then you'll get a chance to ask them questions. We'll take questions from the audience here live in Aberdeen. And for those of you online, you'll also be able to submit questions. So we've got a really, really exciting day ahead of us, and I can't wait to get started. And to get us started, we have Charles Taverner, CEO of FlyLogix, and Charles will be giving the keynote speech, and you'll hear from him very shortly. FlyLogix is a UK-based company. It's a young company. It's a very fast-growing company, and they have a really exciting technology, drone technology, which can really help make the world a better place. So without any further ado, I'd like to welcome up Charles to the stage, please.
Thanks very much, everyone. It's an absolute privilege to talk to you today and to such a talented audience. So just want to speak to you for about 10 minutes and cover off three things. So first of all, the why of what we do at FlyLogix. Then I'd like to talk to you a little bit about the journey we've been on. And then finally, I just want to finish off with a little bit about what we call learn by doing and what that really means to us. So if I start off by talking about the why of FlyLogix. So aviation has a problem. If you look at almost every industry, including the energy industry, they have a global greenhouse gas emission curve that goes up, and then between 2030 and 2050, it starts to drop off. If you look at that curve for the aviation industry, there is no scenario where it drops off. I think the most optimistic scenario, it flatlines, and that is an incredibly optimistic scenario. Now, the interesting thing is that is not through lack of trying on the aviation industry's part. Actually, it's been focused on efficiency for many, many years, more driven by an economic requirement, but efficiency has been a big focus in the aviation industry. But the challenge is you're fighting two sort of macro trends. One is it is just fundamentally an energy intensive activity, putting a large object into the sky. And the second thing is our demand for aviation is insatiable. We are constantly wanting more and more aviation services. And so when we set FlyLogix up, what we were looking to do was take a portion of that aviation industry and do it more efficiently with small uncrewed aircraft. Now, I don't believe that I will fly for many, many years in a passenger aircraft where I'll be happy if there's not a pilot up the front of it. But if you look across aviation, there are loads and loads of applications that would be better done uncrewed. And the example we always give is the police helicopter. So a police helicopter is a 2,500 horsepower aircraft. It usually flies with 2 or 3 people in it, and it flies a GoPro. And it has no other purpose. If you look at what a police helicopter does, it doesn't pick up casualties. It rarely moves people to site. That is a 2,500 horsepower aircraft flying around with a camera. And actually, if you dig into aviation, there are loads of these activities. And our objective in FlyLogix is to pick out those activities and start to move them to an uncrewed world. But as all of you in this room know, technology businesses are about focus. And so what we set out very, very early on to do is find something where we could impact overall aviation mission services, and actually we could make a positive impact for another industry. And where we ended up was greenhouse gas emissions, so measuring methane of offshore facilities. So we can do that much, much more efficiently with a small uncrewed aircraft. So if we put the video up, I think that'll probably show you what we do. So this is what FlyLogix does. So, over in the left-hand corner, you see one of our aircraft. They fly from the shore out to offshore assets. They fly around those assets and they measure the methane emissions of those assets. And if I talk a little bit about the journey we've been on to get there, then you can start to piece together where we've come from. So actually, if you go all the way back, all life is a journey. Actually, probably aviation entrepreneurship for me started when I was 14, and I had gone to see Top Gun, and I actually went and bought a Lightning fighter jet from the RAF. So that's probably the genesis of my entrepreneurial career. And my mum's even got a photo of me on the phone to the RAF trying to negotiate that. But if we go and talk, very intense look on my face. If you go through, the real genesis of FlyLogix was back in 2015. So we founded the business in 2015. The first operation we did was for Centrica. So we flew from Blackpool out into Morecambe Bay. And I'll be honest with you, we thought it was about measuring methane for a safety perspective. So my first, when the business started, we thought it was all about measuring methane for a safety perspective. In 2018, BP's credit completely, they had the insight. Actually, the more important thing here is using that in order to measure the emission levels. So in 2018, BP said, could you go out to Clare and measure the emission levels of Clare using that same equipment? So in 2019, we did that first operation. So if any of you know your geography of Shetland, we went to a place called Papa Stur, which is a small island to the west of Shetland, because that made it easier for all the other aviation users. It has a population of 6 people, and we took it over and raised the population to 12 people. And we flew that first mission. We flew out to Clare, and we got a very simple emission profile, just the very simplest emission profile. Then in 2020, we went back to all of those West of Shetland assets that BP owns, so Glenlyon, Clare, Clare Ridge, and we did multiple flights, and we showed we could get to a point where we could make a meaningful emission. But I will be frank with you, it wasn't good enough. What we then did is we came together with Net Zero Technology Centre, Equinor, Shell, Total Energies, TACA, and Harbour. And we did a long series of flights up in West of Shetland, in the northern North Sea, in the central North Sea, down in the southern North Sea, and we refined that technique. So we went from a place where we could make a meaningful emission measurement to the point where we could make an emission measurement that had real value. Roll forward this year, we're still working with those 6. We've added to that Neptune, Repsol, Serica. So you can see we're now, I think that's more than 50% of UK production where we're able to go out and make measurement of their methane emission levels. We're using that foundation in the UK to start to take that service overseas. So we've opened an office in Norway. We have started down the path of doing work for a number of different operators in Trinidad and Tobago. So we're taking that operation overseas. And then we're just starting to step sideways into some of the other applications. So wildlife monitoring for the wind energy industry using that same platform. So you can see that sort of incremental learning as we go through it. So let's just talk a little bit about learn by doing. So I passionately believe that technology development, like everything else, is about practice. And so what we do is we go out there and we try and do things and we learn. Now, what does that mean? That means we fly, so we actually get planes in the air flying. We actually go and fly to customers' assets with all the pain and the tension that goes with that. And we don't believe in the status quo. So certainly when I started the business, lots of people, and in fact, there are still forums that will tell you you cannot do what we do, where you fly long distances from the shore out to assets. Lots of people who want to talk about that. We've not believed the status quo. What we've done is we've gone and asked people respectfully, here is our safety case. Can we go and do this? So we've learned by doing. What I would say about that is there is an overhead with that. So my friend at Transocean describes it as chronic unease. So for us to be successful at that, we have to be in there is nowhere to hide if you go out and deliver for customers. Not everything goes right all the time. And so you have to have that state of chronic unease. We're always looking for the next problem. I sleep with a notebook next to my bed. And I do wake up in the middle of the night and sometimes write things down and ring my team in the morning and say, have we thought about that? But I love what we do. So I am passionate about what we do. I genuinely believe we're making a difference. I enjoy it. It comes with a bit of an overhead. But the other thing that is really powerful about what we do is other people are helpful. So I think it would be wrong to believe that that is a FlyLogix achievement. FlyLogix is just a little bit of a much, much bigger picture here. So you have a whole group of customers that are making this possible. You have groups like NZTC that make this possible. We have incredible support from the Civil Aviation Authority, from National Air Traffic Service, who run all of the aviation operations in the UK, and frankly, all the helicopter and airspace users. So, this is not a single output. This is something where lots of people come together. And I would encourage you to push your own things, because actually most people around you want to help, want you to be successful. And that has been our experience through this. So I'm really excited to listen to everyone's stories today. It is a really fun journey, and it is, you know, we're only just starting on that journey. But thank you all for the time to present to you, and let me know if I can be helpful with anything you're doing.
Thank you very much to Charles Taverner, CEO of FlyLogix. So now's the really exciting time when we hear from our first pioneer. And the first pioneer is going to be Inketsu, who is dialing in from Japan, and he is from PJPI. Inketsu, please. We can't hear you yet, Inketsu. We're still working on sound, so if you keep talking, Inketsu, we can test it out. We can't hear you yet, I'm afraid. Can you check that you're not on mute to ask a daft question?
The mute. Okay. Sorry about that.
Thank you, Inketsu. Welcome. So please start. You've got 5 minutes.
Okay, thank you. So hi, I'm Inketsu. I'm Director and Chief Intelligence Officer of PJPI. I'd like to start out by telling a story about when I joined PJPI. I met the CEO of PJPI in the summer of 2019. The CEO asked me to join PJPI, but I rejected once because, to be honest, I did not believe in their technology. I felt their technology was too good to be true. But the next week, he invited me to have a dinner at one of my family's Chinese restaurants in the center of Tokyo. The CEO of PJPI is called Hiroaki Nishina. He has been a serial entrepreneur for more than 30 years and experienced some billion-dollar exits. After being successful, he became a philanthropist, and he was running 2 NGOs in the United Nations, helping children in refugee camps in Kurdistan fighting against ISIS. When he went to the front line of the war in 2015, and what he found was hopeless and despaired face of children of similar age to his 3 daughters. At night, there was no sound and there was no light. The next morning, he gave children soccer balls. He expressed the moment as the smiles and laughter of children shone like a diamond in the war camp. After coming back from Kurdistan, he discovered this sustainable battery technology developed with Kyushu University, and he bought the technology at $5 million USD in 2016. In that restaurant, he said, the reason why I founded PJPI was that I wanted to give equal opportunity of energy, education, and healthcare to every child on the planet. You may wonder what's can you go to the next slide? So you may wonder what's sustainable about this battery. This battery solves a lot of limitations of conventional lithium-ion batteries listed here. Without solving these problems, there is no net zero. Can you go next slide? Our solution is PJPI developed high-performing batteries using diamond-like carbon produced from agricultural products like cotton and waste of olives. Our technology would reduce about 96% of CO2 per megawatt compared to conventional lithium-ion batteries in 15 years. Can you go to the next slide? I'd like to relate our technology to something Scottish. Annually, there are 5 million tons of waste created by drinking whiskey. We need to assess whether there is enough fiber to make our carbon, but please imagine how sustainable Scotland would be if we could recycle all of this waste into batteries. Next slide, please. We have not made whiskey-based batteries yet, but our cotton-based batteries have the following impressive performance. Firstly, our battery has no risk of explosion. And because it does not have the risk of explosion, we can charge our battery up to 10 times faster than conventional lithium-ion battery. Also, based on the life cycle test, our battery can last more than 20 years. This is very important benefit for net zero. Also, our dual ion chemistry-based dual carbon battery has 5.2, which is 5.2 volt, which is one of the most powerful batteries in the world. That can be game-changing technology for EVs, electric airplanes, and marine applications. And thanks to TechX support, we will be able to mass produce it by 2025. Can you go to the next slide? After talking to many big energy corporations in the program, we have identified the sweet spot of our application to be 500 kilowatt to 1 megawatt portable energy storage. 5 out of 5 that we talked with showed interest in portable ESS system that is safe and long-lasting. Can you go to the next slide? Our team consists of people who are passionate about making positive changes in the world, and we are supported by top battery and material scientists at Kyushu University. Can
30
you go to the
seconds
next
left.
slide?
Carry on, Inketsu, 30 seconds.
Can you go to the next slide? Our revenue since foundation is about $3 million USD, with expected revenue in 2020 to be more than $50 million USD. Currently, PJPI is running Series A, raising $6 million to mass produce our dual carbon batteries. In fact, we got purchase order from Hitachi yesterday, potentially $9 million USD. Can you go to the next slide?
I'm sorry, Inketsu, but you're out of time. I'm very sorry. But thank you very much to Inketsu. So now I'd like to welcome Amir from Repair. Amir is here with us, and he's going to pitch his technology. Amir.
Hello. Hi. Hello. Hi. Thanks very much for the opportunity. Thanks very much for the program. I'd like to take you on a tour to a very special place, the lowest point on Earth, the Dead Sea. It's also one of my favorite spots. Located in the Jordan Valley, between Israel and Jordan, this is a very unique lake. Next slide, please. 400 meters plus below sea level, and the water that is so salty, you can just lie down, float in it, and read your morning newspaper in it. Next slide, please. For millions of years, the Dead Sea has managed to maintain a very delicate balance or equilibrium when fresh water comes from the Jordan River at the north, and an evaporation that happens and balances such that the level of the sea has been kept more or less constant for millions of years. A very delicate and gentle ecosystem. Next slide, please. But in the last couple of decades, things started changing drastically. The Dead Sea is now receding fast. It's dying. And this is due to a blunt human interference in this gentle, delicate ecosystem. You know, I swam here once. The water is miles away nowadays. Next slide, please. With climate change, the cause of what we are now experiencing with the climate crisis comes from a similar human interference in the ecosystem. And we, in the Mediterranean basin, really feel it on our daily life, where our climate becomes more and more desert-like. Next slide, please. What needs to be done about it? It's clear to all of us. We need to shift to renewables as quickly as possible, and we need to stop emissions. But will that bring us to net negative by 2050? Only that? Next slide, please. Probably not. What needs to be done in addition is to proactively capture carbon dioxide from the atmosphere and somehow store it or remove it by direct air capture and similar technologies. The challenge or the problem with direct air capture technologies, the main problem is their immense energy consumption. It's just huge energy consumption. And this is what we kept in mind when founding Repair. Next slide, please. So we have been developing a technology that is very efficient, affordable, sustainable, and scalable. So let's see how it works on an animation in a nutshell. Go ahead. Our technology is based on an innovative electrochemical cell that comprises two identical electrodes and a separator sandwiched between them. We stream atmospheric air inside the cell and trigger an electrochemical reaction that selectively removes CO2 molecules from one side of the cell through the separator and takes it to the other side of the cell, such that eventually clean air goes back to the atmosphere while pure CO2 streams out for utilization and storage. This is a very efficient, cost-effective process that requires only a fraction of the energy of other direct air capture solutions. This is a multi-cell technology that works at ambient temperature and relies solely on renewable electricity to operate. It can seamlessly integrate with existing infrastructure of utilization and storage. So our technology is cost-effective, sustainable, scalable, and we are at Repair are redefining direct air capture for a carbon net negative world. Thank you very much for the opportunity.
Thank you very much. Thank you very much, Amir. So we now have our third pioneer up, and this is Matt from Brayfoil Technology in Johannesburg in South Africa. Matt, over to you.
Thank you so much, Mark. Hello, everyone. I wish I could be there today, but thank you so much for having us digitally. I think you can press next slide and we can get started. So this is where we find ourselves today in the ended TC. And this fantastic organization has been giving us so much support. But today I want to take you guys a little bit further afield, all the way to our corner of Africa and to a place called the Marakele National Park in South Africa, to tell you a story about food poisoning, the worst food poisoning of my entire life. And it was spring here, at least 30 degrees Celsius in the shade. And I'd been sick for about 2 days in a tent. I was not a happy camper, very my definition. It was a father and son trip, and I was 16. My father had found ways to entertain himself while I was stuck at the main camp in the valley. And he did so for hours and hours in one particular spot. You'll notice that the landscape has some great elevation here. And he was on the top of one of these ridges with his binoculars. Watching what, you might ask? Next slide, please. This is a Cape vulture. He was watching these. They are endemic to the area. They're tremendous slope-soaring birds, able to stay aloft for days at a time. He was watching them fly back and forth across the landscape, taking advantage of the airflows of the cliff faces. And you see Rob, my late father, had been making his own aircraft since he was about 8 years old, experimenting with different wing shapes, learning how their shapes interacted with the air in flight. He saw the way those birds changed the shape of their wings and noticed some pretty interesting relationships. That set his mind to thinking, what if we could do the same with man-made wings to make them change shape? That was the start of a 2-decade journey of prototyping, experimentation, and finally patenting of a unique idea. In 2017, on the back of that work, I moved back to South Africa from my career in finance in Hong Kong to start Brayfoil Technologies with him. Next slide, please. Since then, we've raised £2 million and built a team of experts to apply his initial concept. We've started looking at aerospace applications, but then our path led us to wind energy. And that path has led us onto the screens of the Net Zero Technology Center today. Next slide, please. We stand at a crossroads from the perspective of climate. The IPCC reports have made it very clear that the pace of decarbonization has to increase in order to avoid the worst effects of climate change. What that means for wind power is we need to double the amount of turbines being installed every year by 2030. What does that mean for the devices themselves? Next slide, please. we're going to need more turbines with larger average outputs. So from 200,000 turbines in the ground today, we're going to need an additional 580,000. And those devices have to get better. Next slide, please. There is, however, a problem with that. As these turbines get larger and their blades get longer, the weight and costs of those blades increase exponentially. The reason for that is that the aerodynamic forces on those blades are increasing exponentially as well. So how do we solve that problem? Well, nature's already solved that problem to a certain extent. Next slide, please. Birds' wings change shape when they fly to adjust the loads and how they engage with the air. What if we did the same thing with turbine blades? That's exactly what we at Brave4 Technologies have designed and built. We've taken the shell structure of a turbine blade and we've enabled that to morph in a very simple, commercially viable way to give you different lift and drag characteristics as required. That means as the wind speed goes up, we can change that shape to decrease those excess loadings while still producing the perfect amount of power. That enables us to have longer blades on the same base. So right now we're forecasting about 10 to 15% longer blades, which results in about a 20% annual output increase, a massive step change for the industry. Next slide, please. From an impact perspective, wind energy is already set to be reducing almost 10 times that of EVs and ocean shipping from an emissions perspective. We want to take that to 30 gigatons more with Brave4 Tech. Next slide, please. Our customers, we're looking at supplying the wind turbine industry. It's about an $80 billion market, and it's split between 6 to 10 major players, which we want to license our technology to. Next slide, please. I'm running out of time here, so next slide, please. Next slide, please. This is our team split across a number of different competencies with international mentors. Next slide, please. Next slide, please. TechX has really opened up the wind value chain for us with meetings with all of these players, showing our technology is tremendously valuable. So thank you for having us today.
Thank you very much to Matt from Brave4. So we've heard from 3 pioneers already, and we've got another 3 up. But before we move on, I'd just like to remind you to get some questions ready. And these could be questions to individual pioneers, or better, they could be more general questions that 1 or 2 pioneers could answer. So if you're joining online, the way to do that is through our Menti code, which should be on your screen. So I'm now delighted to welcome Grace from BX, who's going to pitch to us now.
If you are an asset owner that's extracting oil and gas today, this image will be very familiar to all of you. Today, if you are an asset owner, what's on your mind is whether this asset is going to be safe. And for the past 50 years, the way that we have been keeping this safe has never changed. Next. Whether we are using human divers or underwater robotic systems, the method of deployment has always been of large and expensive vessels. Other than just putting 40 to 60 change, we are seeing a lot more infrastructure installed underwater. When seawater level rises, countries around the world are installing coastal protection to protect their coasts. But more importantly, as we transition towards net zero, we are installing renewable energy at a much higher density compared to ever before. We are seeing 15 to 25 times more infrastructure that needs to be protected. And this means at this point in time, we cannot do things the same way as before. Next. Today, we are spending $7 billion annually on underwater robotic systems that are controlled and deployed off large vessels, but that's only part of the problem. We spend another $20 billion on building and utilizing large vessels and another $25 billion to analyze the data that we are collecting from it. Next. BX is using hovering autonomous underwater vehicles designed like self-driving cars to allow for inspections at scale. We want to target and focus on shallow water inspections because this is where renewable infrastructure will be installed in the next decade. Using our proprietary sensor fusion technology, we are able to detect and track objects in murky conditions and achieve generalization of our autonomous behavior even for structures that we have never seen before. We are now able to do it off a cloud platform for reporting, where asset owners and service providers are able to immediately collaborate on the data that's being provided, understanding how their infrastructure changes over time. Next. Today, we have demonstrated this capability of the smallest vehicle in the world for autonomy underwater. And that vehicle over there that you see is two-man portable. Just last week, we were able to detect and inspect the monopile of ORE catapult at the Newcastle facility. And we are really excited to be able to scale up this technology to the offshore wind industry. But at current point, using just a prototype vehicle, we are already able to significantly reduce the risk to personnel, the amount of cost saving, we are able to increase the cost savings to asset owners and significantly reduce their CO2 emissions when using autonomous systems. Next. Our business model is to sell and lease our vehicles to service providers that are now able to use our technology to improve their operating profit and overcome the skills labor shortage that they have today in carrying out these inspections. Asset owners also work with us to use our portal to understand their infrastructure and use the data that's being collected at a much higher density to understand how to predict when the asset will fail or may fail. Next. My team is strong, passionate, and diverse. We have 14 people spread across mechanical, electrical, and software engineering. And I have been building underwater vehicles for about a decade now. Hopefully, I don't look like it. But what I saw in the industry was that there was a stagnation in the robotic systems that were controlled by human. It is not scalable at all if we continue the same way, and we believe that autonomous system can help us break past the current boundaries that we are facing today. Next. We are really grateful for TechX because it provides us a soft landing ground to UK, where there's the largest space of offshore wind, which is our particular area of focus in the next 5 years. I'm really thankful for my mentors to be able to iterate the business plan with me and really sharpen how we are going after customers, who are the people that we should be targeting, and growing myself personally to help the company grow further. Next. BX is currently seeking pilot deployments with offshore energy developers that want to conduct inspections in a completely different way. We are also raising our pre-Series A round in 2022, and we hope to talk to all of you who may be interested. I would just like to share that we think that if we want to really achieve net zero, we really cannot just be building more and more new things that does things the exact same way. Autonomy can help us unlock that and break free from the past that we have built up. Thank you.
Thank you very much, Grace. Next up, we have Lucas, who's joining us online from Honeyworks. Lucas.
Hello, Aberdeen, and to those joining virtually, greetings from New York City. I'm Lucas Wisman, co-founder along with CEO Lee Wilson of Honeyworks. Honeyworks is a subsea robotics company located in Northeast Scotland, and we're developing a game-changing technology that will shake up the world, how the world works subsea. Next. Subsea robots have been used for decades in an effort to reduce the reliance on divers because of the inherent dangers. Robots connect subsea assets electronically and hydraulically. They inspect and measure components and systems, and they make repairs to assets. Next. The robots still rely on expensive, dirty, crude vessels to transport the robots to the worksite and deploy them into the water. Stakeholders, some of which who we met with at TechX, tell us that this approach isn't sustainable based on both cost and carbon footprint. Next. The offshore energy industry spends about 20 billion annually on underwater work, with a huge amount of that spend driven by vessels. The defense industry needs to monitor a vast seabed containing assets and infrastructure that are under constant threat from bad actors, threatening national security. The rest of the world is developing new technologies for farming the seas, performing science, and something very close to our hearts at Honeyworks, restoring subsea habitat from the destructive practices of humans going back decades. Next. Loggerhead is an all-electric approach for deploying subsea worker robots. By harnessing the latest advances in energy storage, machine autonomy, it enables the entire operation to be managed by humans from shore at a fraction of the cost and emissions. The system uses a large autonomous underwater vehicle, an AUV, to navigate to the worksite subsea, and then it deploys a communications buoy to connect with humans located on shore once it's arrived. After the connection is made, it deploys the worker robots. Next. Loggerhead uses a patented edge cloud communications and control platform to enable distributed stakeholders on shore because they no longer need to survive the splash zone when they're deployed from the surface-based vessels. Smaller robots mean less energy required during the operation. Not having to pass through the splash zone also means that Loggerhead won't be dogged by the bad weather that causes delays and interruptions in work that are commonplace with surface-based approaches. It's an all-weather, all-season approach for working subsea. Next. Loggerhead's collaborative autonomy engine enables the AUV and the ROV to work together during an operation, which saves energy and helps mitigate risks associated with intermittent communications channels. This maximizes efficiency of the machines at the edge and offers high operational reliability. Next. Beyond 50% cost savings and elimination of emissions, Loggerhead enables the skilled resources to be moved to shore, reducing safety exposure while enhancing the diversity of the workforces by opening up the door to those who would otherwise be left out because of the demands of the offshore environment. Because stakeholders can dial into the operation from anywhere in the world, we unlock resources that would otherwise be tied up offshore, which allows us to deploy them in real time to the tasks that make highest best use of their time. Next. Our Edge Cloud software platform allows us to integrate with our partner platforms to unlock value by combining the power of subsea launch systems, distributed communications and control, and collaborative autonomy. Next. Our team has over 100 years of combined experience developing and commercializing robotics technology and services. We've been leaders in subsea robotics projects that were a fair share of setbacks, and those challenges. Now, if you're a super talented engineer who wants to help us build the future of subsea work, we're hiring. Next. HONUWorks is creating the future of subsea robotics work. These are some snips of video from the simulator, which was built with support from the TechX program. To join the growing number of offshore stakeholders, field service companies, and technology partners who recognize the potential of the HONUWorks approach, please reach out to us. You can find us on LinkedIn or by visiting our website at honuworks.com. Next. Thank you.
Thank you very much, Lucas. And finally, in this session, we have Marcus from Dunia, who's joining us in the hub. Marcus.
Imagine Johnson Matthey and Google had a baby. That's Dunia Innovations. What we are trying to do here is removing the bottleneck of scalable carbon utilizations. Next. Can I have a show of hands? How many of you came here by plane? Most of you. Well, I did as well. And next. Did you know aviation accounts for 2% of the global emissions? And as Charles has already mentioned earlier, and it's not sustainable and it's going like up higher and higher per year. Next. Look, growing up in Malaysia, I've seen what humans can do to the environment in firsthand. And in fact, I don't really enjoy flying that much. So it's been 5 years since I last went home. But I'm here today because I realized the value of this session over here. And I realized how important for me to talk to all of you today. Next. What we are trying to do is basically take the carbon dioxide released by the industries and reverse the whole process back into chemicals and fuels and reducing carbon dioxide at the same time. But currently, the problem that we have is the catalysts. Next. According to our case study for this one process, CO2 to ethylene, we don't have efficient enough catalyst, and the catalyst at the moment is not selective enough. What we need to hit is the target economically viable process zone. And based on our conservative estimate, we can have cost reductions of up to $400 million. Next. And why are we not there yet? Well, we are not there yet because the current innovation is way too slow. It takes about 20 years to produce one catalyst in these innovations. And that's because the combination space is way too large, and we currently have pretty poor data at the moment. Next. And then in Dunia, we plan to disrupt this whole paradigm by speeding, with our technology, we can speed up the whole process from 20 years to 2 years. And the way we do it is by using AI to navigate through the catalysis space. And the robots that we have will ensure us to generate high quality data every single time. Next. Let me show you what I was talking about. Yeah, you have carbon dioxide, water being converted into fuels with the help of catalysts. And what we have at the moment, the energy barrier is way too large. And when you take renewable energy into account, the process costs will go through the roof. And in Dunia, we are coming up with new sustainable catalysts to reduce the energy barrier, thus reducing the process costs. In Dunia, we go through this design, make, test, analyze cycle, where we have state-of-the-art AI to design those catalysts for us. And with our robotic tools, it can perform high-throughput experiments day and night, 24/7. And not only are we making our own catalysts, we are testing them as well with the high-throughput units. In these testing units, we will test carbon dioxide and water to different chemicals and fuels. And when this process is done, we'll further analyze them in terms of their efficiency, their stability, their selectivity, as well as the economics of the whole process. And research has shown that this sort of active learning approach can bring down, reduce the cost to market, the time to market by up to 90%. Next. Timeline, I'm here with you today. As we are speaking, we are building our platform for hydrogen production, and we plan to upgrade the system to CO2 utilization by the end of the year. And look, developing hardware is not cheap. That's why we have raised over £1 million today. And my intention being here with all of you today is to co-develop some projects next year. And we plan to start raising seed at the end of next year to expand our team and expand our lab to more different processes. Because what I've told you today is just CO2 to ethylene. It's just one process. There are 50 other more different processes that we could achieve. Next. You have myself, Marcus, here speaking to all of you today. We have Alex and Ahmed with us as well. We are pioneers and experts in the field of catalysis, computation, automations, and business. But what unites us is our sense of urgency to save the planet. We have our brilliant advisors. That's Adam Hiller, from ex-CTO from Shell, and Troy from Head of Industries ABB, and our technical advisor Paco, whom is a director of ETH Catalysis Hub in ETH Zurich. And big shout out to TechX, because without TechX, we wouldn't be here today. TechX, this NZTC program really brought like Ahmed, Alex, and I together in the get-go. Next. So with that, we are looking for the catalyst of the clean energy future. The catalyst can be carbon nanotubes, metal oxides, or you partners today to propel us, catalyze us to the next step. Thank you.
Thank you very much, Marcus. So now we have our panel Q&A. So we'll just invite Marcus, Amir, and Grace to the stage, and we just need to get set up. Great. So do we have a question, please? Anyone here in Aberdeen with a question? No? Yes. Jerome. So if you could announce your name, Jerome, and company, that would be great.
Yes, Jeroen van Durk, Equinor Ventures. I have a question for Amir, because you presented a great technology for capturing CO2. But could you say a bit more about what happens after that with the offtake, what your plans are, and if there's any agreements already in place?
Yes, we are actually strategically are going to focus on the capture element of the value chain. This is the most difficult, technologically challenging part in this value chain. And principally speaking, CO2 that we capture or that any direct capture technology captures can either go to sequestration, long-term storage, or utilization. So we intend to continue focusing on the capture element and partner with suitable players that excel in either long-term storage or provide CO2 as feedstock for making products like jet fuels, for example.
Thank you, Amir. And I'm now going to take an online question, and this is going to be for Matt. We've heard a lot about what you've achieved in the last 15 weeks, but what excites you about the 2 years ahead, Matt? I think you're on mute, Matt. Not yet. Keep talking. We can't hear you yet. Okay, I think we'll have to ask that question to Grace. We got you. We got you. Please go ahead.
Yeah. Okay, perfect. Yeah, what excites me about the 2 years ahead is really the confluence of attention on the climate space for all of these companies and the massive policy pressure that's occurring in all of these industries. I mean, just looking at wind, the pressure to have energy independence in combination with net zero targets means that there's a really bright future ahead for all of these technologies. And I think leveraging the support that governments are providing as well as private investors is going to be really exciting for all of us. We're putting up our first pilot in the next few weeks, and then hopefully scaling our technology to be market ready within the next 2 to 3 years. So exciting times ahead for all of us, I think.
Thank you, Matt. Yes, Colette.
Hi, Colette Cohen, the CEO of Net Zero Technology Centre. I actually have questions for all of you, but I know I'm not allowed to ask them. So I was going to be curious, I was going to hit the catalyst one because kind of there's a whole molecular issue across virtually all of your activities. And you picked CO2 to ethylene. But looking at the biggest sort of challenge we have, what are your other sort of top 2 or 3 processes that you would like to address with sort of really innovative catalysts?
So I think ethylene is one of the prime example for us because it's one of the most important base chemical that there is out there. In fact, most of your clothes that you're wearing today, ethylene is involved at some point. But in terms of other processes, we are also interested in looking at methanol as well, obviously. But it is our intention and dream and hope is to be able to convert CO2 directly to aviation fuels. That's our ultimate goal. Yep.
Thank you, Marcus. So I'm now going to take another one online, and this is for you, Lucas. So HonorWorks is Aberdeen-based. What benefits do you see you as a company bringing to the northeast of Scotland over the next years?
So as we're growing, I think we can offer another technology, a path and development for helping Aberdeen maintain its leadership and thought leadership in subsea robotics, specifically for operating offshore.
Okay, thank you. And Grace, can I ask the same question of you?
I think for us, it's very heartening when we see that people that were previously not in the industry able to use this technology to serve their regional wind farms. You know, it really opened up the opportunities available, independent of whether you have like studied sonar or like underwater navigation. You can just be able to drop a vehicle and acquire the data to keep the infrastructure safe, ensuring that this kind of renewable infrastructure can be scaled up without having to deal with costly repairs.
Thank you. Any other questions from the room? Yes, question there, Erin.
Hi, Erin Halleck at BP Ventures. I've got a portfolio company that's actually very, sorry, I'm getting weird feedback. I've got a portfolio company that's very similar to BX and Honeyworks, and one of.
Yeah, go ahead.
Okay, I'll speak up.
Grace?
So what we have seen is that despite the unit economics for wind being a lot more competitive than oil and gas, when you come to the actual inspection tasks to be done, they are still using DP2 vessels to carry out the work, which means that the cost of doing that job, even for wind, is still high. When we are transiting towards using autonomous systems to carry out the inspection, what we essentially can do is to dramatically reduce the cost, because now we can deploy off more flexible infrastructure such as on the wind turbines itself, and using the existing infrastructure such as the smaller vessels that has already been contracted for 5 years on site to actually carry out the inspection. So you don't have to deploy back assets specifically just to do that work. And that's what autonomy unlocks, which is why our core focus has always been on the autonomous behavior rather than any other thing of the robotic ecosystem. Yeah, thank you.
Thank you. I'm now going to ask a question from the online audience to a number of you, but Inketsu first. What was the most useful thing for you about the TechX program that we're completing today?
For me personally, I think among the sessions we have received, the most valuable skill that I gained was storytelling, because yeah, it's basically a very powerful tool, and I didn't really get practical learning of storytelling before, so it was a good skill to learn. And also the customer discovery process and investor first process was very valuable as well to gain experiences.
Thank you. And does anyone here want to come in on that? Amir.
For us, definitely customer discovery was key. Exposure to potential strategic partners, better understand their future needs, better understand their mindset was really important. And this platform gave us the opportunity to meet with the right people in the organization and ask them questions. You know, we normally, those who answer the question, not asking the questions. So that was really important in that scenario, unique in a way.
And Matt, the same question to you. You're on mute.
Thing for us was really green on my side. Yeah. Yeah, so I think that the most valuable thing for us was really the ability to engage with the customers that you put us in touch with. You know, you've got such great reach, TechX, such great networks, and understanding the ecosystem was much easier with you putting us directly in touch with the right parts of these businesses, as well as the overall ecosystem within the UK and in net zero technologies overall. So I think it set us all up really well to be able to engage with those ecosystems as we grow and understand the value of our tech.
Thanks, Matt. Grace or Marcus, you want to add anything?
I think all the pioneers have covered pretty well so far. So I think what I would like to say is that people often overlook is the people. So like with this program, I think I really appreciate the fact that we have so many different pioneers working on different fields, but towards the same goal. And I do see a lot of synergy between different portfolio companies like just around to work together in the future.
Thank you. Any other questions from the floor? So we'll go online again. Scotland, we're in Scotland now. Scotland has the opportunity to be a clean energy powerhouse. And we'd like to get the view of several of you as to how you can contribute to that and what that opportunity brings. And we'll start with you, Matt, please.
Sure. Yeah, I think that Scotland is incredibly well positioned to position itself in the offshore wind industry in particular. You've already started doing that with all the ScotWind projects and the auctions that are happening. But building those competencies in the UK and in Scotland in particular will be tremendous. The ability to network in the North Sea, its offshore wind energy infrastructure, hydrogen generation, and all of the ancillary industries means that you're really well positioned to do that. I'm excited to see what the other pioneers think apart from just wind.
Thank you, Matt. And we'll go to you, Grace, please.
I'm still learning about the broader UK infrastructure, but I think what's really exciting is that there's a focus in doing this, and when there's that focus, then the surrounding technologies like what BX and the fellow pioneers have built can accelerate that. So, yeah.
Thank you. Inketsu, can you take that question, please?
And because we are a battery company, what we can contribute is energy strategies for wind turbine and also EVs. And we are actually building edge computing data center as well to support a 5G network for everywhere. And yeah, there's actually energy strategy is essential for net zero. So I think we have a lot to contribute.
Thank you very much. Lucas, Amir, do you want to add anything?
I'd like to add one. Can you hear me?
Yep.
Okay. Yeah, I think for as an American, I think what's really special about the UK is there's a clear commitment to the transition, and with those clear commitments, it helps folks make investments and feel confident in investing in that future.
Sorry, Yvonne, I just want to add one thing. I think what I have experienced is that sometimes when the world has this problem, we start to want to fix it. And then we build a lot of things, but we forget about how to take care of them. So specifically for BX, right, I think it's important to always understand the whole life process of what happens when you install something and how to prevent the lifetime cost from affecting the future generations, especially when this is such a critical point in our world.
Thank you. Thank you to all six of you. That was fascinating. We are now out of time. So that concludes part one of Demo Day. We will now take a 20-minute break and we will see you very shortly. Thank you.
I hope everyone had a very nice break. My name is Laure Mora. I'm the TechX delivery lead. I joined about 4 months ago, so about at the same time as our amazing pioneers started their program. So it's been quite a journey. And as you can see till now, it's been absolutely exciting. And now we're going to go for the second half of the cohort. Same as before, please keep your questions till the end. Write them down online. You have a Menti code that you can use to pop your questions virtually. And we'll have a Q&A panel at the end where we'll take all the questions. Right. Our first pioneer, they're based in St. Andrews, not far from here. And their company is focusing on zero-emission marine. Please give a big round of applause for Dr. John Irvine from ZemFuel.
Okay, it's really nice to be here. Been a lot of very nice, interesting presentations. I'm afraid I'm not going to take you very far. Let's say Beach Boulevard. Go down there, look at the North Sea. That's one of the world's greatest potential sources of renewable energy. So there's gigawatts coming on stream in the next year, 2 years. How are we going to use that? It's going to be green hydrogen, perhaps. And the best way to move green hydrogen is probably as green ammonia. That's our fuel. That's what's driving us. So zero emissions marine. Next slide. So we've been looking at the marine source for a number of years. It's one of the biggest problems in the world, and it's one of the slowest moving actors. There's been not a lot of traction until the last year. So ZEM has ramped up this year, and this is becoming a really important and really leading sector. So initially we're looking at removing exhaust gas emissions, SOx and NOx emissions. Clean air is as important as a climate change. It comes back every so often, but millions of thousands and hundreds of thousands of people are dying every year from poor climate. Now we want to focus on reducing carbon emissions and looking at green fuels. So the two fuels that are most relevant to marine are ammonia and methanol. And we're now looking to implement electric fuel cell drive on ships and boats. This is more efficient and much less emitting. Next slide. So in terms of the marine sector, it's about 3% of global CO2 emissions at the moment. That's going to increase as we move more goods by sea. And indeed, as a percentage, it's going to increase because the marine sector is perhaps the slowest to respond. So there's a huge need to improve capability here. There's also a huge market. And it's very important that we don't scrap current technology, that we transition and upgrade. Hydrogen is an ideal green fuel, but it's not energy dense enough for these large applications. You need a liquid fuel. Diesel is perfect, but it's not low carbon. Something between diesel and hydrogen is either methanol or ammonia. So next slide, please. So, So we feed in ammonia. That actually splits in our fuel cell, nitrogen and hydrogen. That hydrogen reacts, goes through the membrane of the fuel cell and forms water. So we convert ammonia into nitrogen and water and electricity. There's no NOx and no ammonia slippage. Next slide. We're building on a recent UK-funded project. So we'd now like to show you that we can deliver. So in University of St Andrews, one of our partners in that lab, we were able to show that we got direct conversion. All of the ammonia that went in was converted into either hydrogen or electricity. We had no slippage of ammonia, and these cells ran for 250, 500 hours in the lab. Next slide, please. Next slide. We then scaled this up and implemented within that project a 30 watts cell. And last month we achieved 100 watts in a 3-cell bundle. Now, that may not seem like enough to power a ship, but in a fuel cell system, 1 kilowatt is your basic module. You can get 100 watts with 3 cells. You can do a kilowatt with 30 cells. So we're moving from TRL 3 into 5 through this transition. For megawatt scale, you need multiple units of kilowatt scale units. And next slide, last slide. In the long term, we want to use this for shipping, looking at medium scale boats, research vessels, diving boats. But immediately we want to show that the technology is viable. One is cold ironing, where you charge batteries in marinas. But the other is an auxiliary power unit. So we're looking at a 1 kilowatt fuel cell, 5 kilowatt battery, and we're looking to demonstrate that in the next year. And we have partners actually in Aberdeen Harbour willing to put those systems into the ship vessel. We can go for megawatts, but you really want to show that technology works at sea in the real scenario. So, thank you.
Thank you very much, John. Right, now I want to introduce you to someone who has been drinking insane amounts of coffee because he was based in the US, so he's up in the middle of the night for 15 weeks, attending every single delivery session. That's dedication. Please give a warm welcome to Jim Papadopoulos from T Omega Win. Oh, we can't hear you yet, Jim. Hold on. Can you carry on talking? We're testing the sound.
No, that was my bad. May I start?
On you go, Jim.
Okay. Hi, I'm Jim Papadopoulos. I was born in Lancashire, but grew up in the US. As a boy, I dreamt of becoming an innovative technologist, so I took my engineering degrees at MIT. I co-founded T Omega Wind so I could finally use my abilities on something important, that's climate change. Slide 2. Why doesn't offshore wind power the entire world? Perhaps it would if these big problems could be solved. Giant scale, the most cost-effective turbines are growing beyond 150 meters. Lack of shallow water, while floating designs for deep water double the electricity cost. Weak profits that have been endemic to the industry, and the cost and danger of offshore maintenance. Slide 3. Most offshore wind problems can be eliminated by abandoning the conventional land-style turbine with its slender tower. That cuts weight and costs, eases maintenance, and eliminates infrastructure need. A movable unit optimized for the ocean will provide cheaper energy for consumers and greater wind farm profits. Slide 4. These images illustrate the light construction, shallow draft, towability, rotor held both sides, and automatic wind alignment, the animation at lower right. The reductions in weight and cost are unprecedented. Our design allows local construction and simplifies repair, while quick replacement lowers the risk of new technology. And it expands the locations where wind power is viable. Slide 5. Our unique approach offers a host of exciting advantages. One concerns maintenance. Today, turbines are repaired at sea. The giant crane vessel at right is so expensive, $2.5 million a week to rent, that wind farms accumulate multiple failures to consolidate visits. We pursued shore-based maintenance. Slide 6 with video. In our unique design, a small tugboat robotically swaps a standby unit in hours and repair is done on land. There's almost no downtime, there's no costly ship, and land-based repair is far safer. Slide 7. A major part of our value proposition is towing in nearly any conditions. This exciting simulation from the National Decommissioning Center shows that the world's possibly first wave-riding turbine design can be towed by a small boat in large 6-meter waves. It can even surmount giant 20-meter waves. Slide 8. Our design addresses the supply chain problem. This giant French nacelle alone weighs as much as our entire system, requiring huge cranes and long-distance shipping. Only our design can be manufactured right now, near the point of need by local labor, and then quickly be towed to location. Slide 9. Only our patent-pending design allows easy assembly without any heavy equipment. This shows crane-less erection. Our turbine can then be launched at the waterfront without deepened ports or giant ships. The turbine can easily be towed to location. The single-line anchor is economical in greater depths, and several of our turbines can be installed while a traditional design is still adding chains. Slide 10. TechX support has given us a giant boost. LawTech is evaluating our cost savings. DNV is helping us start the path to certification. The National Decommissioning Center is performing swap and tow simulations, while Strathclyde University will subject a model to giant waves. And the Customer Discovery Program brought enthusiastic validation of our value differentiators. Low capex, fast installation, onshore repair, local content, depthability, size flexibility. Our rapid progress has now interested an international turbine OEM. Slide 11. We aim to offer a turbine with greatest profitability and scalability built in Scottish boatyards for domestic and export sales. The DNV estimated global need is 5,000 10-megawatt turbines per year, a market of $100 billion per year, which by 2050 will avoid release of 2.5 billion tons of CO2 per year. We also hope to open new markets with as yet no offshore wind option, a scope of $20 billion per year. Lastly, our design is uniquely suited to no permit harvesting of affordable green fuel, namely ammonia, possibly the best future role for oil companies. Slide 12. Our experienced team brings a fantastic suite of skills to this challenge. An energy executive, a wind structures expert and professor, an innovator with manufacturing background, a patent attorney, an experienced entrepreneur, and a microturbine business specialist with political background. Slide 13. We are seeking Series A funding of $7.5 million to complete and validate technology development and secure additional fundamental IP. We especially hope to connect to a strategic partner in energy or infrastructure, so our impact can be global. And we're always interested in opportunities to trial at sea with a customer or partner. Slide 14. Winds of change are coming in the global energy sector. Is that 14? And T-Omega Wind is uniquely positioned to provide next-generation offshore wind technology. We're grateful to TechX and our mentors for an incredible 15-week program, and I'm happy to answer any questions now or by email. Thank you.
Amazing. Thank you, Jim. Right, our next pioneer came all the way from Estonia to be with us here today. It's my pleasure to introduce Dr. Einar Karu, from Up Catalyst.
Thank you very much. I will start with why. The why is a very important question. The tipping point is crucial. It's very critical. And what is the solution to that? The solution is, I believe, the deep tech and climate tech technologies with real purpose and impact. With Up Catalyst, we are leading the world to sustainable battery technology for electrical vehicle batteries. I'm Einar from Up Catalyst. Second slide, please. What's the challenge? The EV market is booming. Everybody wants to change their combustion engines to electrical vehicles, but the electrical vehicles need batteries. Next slide, please. The problem, there is no graphite security in Europe. Europe imports up to 98% of graphite it uses, and the same goes for carbon nanomaterials, which are used in battery technologies. Next slide, please. We have a great solution to that. With our technology, electrochemically, we split the molecule of CO2 into pure carbon in the form of carbon nanomaterials or graphite and oxygen. So the only input for our technology is CO2. We break the molecule of CO2 and energy. We need sustainable and green energy. It can be solar, wind, and of course, hydro. And our material is the key to the battery input. In average battery pack, there's about 66 kilograms of graphite, combined also with the conductive additive carbon nanomaterials. In our product lineup, we have multi-wall carbon nanotubes, carbon nanospheres, carbon nanofibers, and graphite. We will target the market at the beginning with carbon nanotubes as a conductive additive, because this is the way entry to the market. But the real challenge is the graphite, but our vision is large. Next slide, please. With our technology, it's a great game changer in the field, because currently how are carbon nanomaterials produced? They are produced with chemical vapor deposition method, and they have huge environmental impact. Per 1 ton of carbon nanomaterials produced with CVD method, around 224 tons of CO2 is emitted into the atmosphere. With our technology, per 1 ton of material produced, we break 3.7 tons of CO2. And about the energy requirements, with the CVD method, you need about 800 megawatt hours of energy to produce 1 ton of material. But for us, on large scale, we need 12.5 megawatt hours of energy to produce 1 ton of material. That's more than 60 times less energy demand. I'm all about basics, fundamentals in science. Chemists don't say it often, but it's all about the physics. Next slide, please. The battery manufacturers are popping up in Europe like mushrooms after the rain. And they need sustainable materials. As I said, there's no graphite or carbon nanomaterial security in Europe, especially with the changing world we have at the moment. So we are really keen that we have proven and validated our materials already with a universal battery, skeleton technologies, and also Imperial College of London. And validation is only continuing even with larger and larger players. We have a great traction already. Next slide, please. Our financial forecast is very large. We have a great vision. We want to grow to 1.2 billion euro revenue by 2030. And how do we do it? Next slide, please. We started with a pre-seed round with 0.5 million euros, which we combined with a grant, EU grant of 1.6 million euros. We built a marine shipping container reactor, the same reactor we have in our lab at the moment. We are able to produce 2 kilograms of carbon nanomaterials a day. And we bring the same technology into marine shipping container. This is currently ongoing. The container will be ready in Q1 next year. And then we can validate our technology at the industrial site. Next slide, please. from lab 2 kilograms a day to marine shipping container 10 kilograms a day to the first pilot reactor 1,000 kilograms a day already to the first industrial site, and then another industrial site in Europe and the US. Next slide, please. We have a great team. Yes, thank you.
Thank you so much. Thank you very much. Right, now if I say wastewater, I don't see many excited looks on your faces. But fear not, we've got someone here who's made wastewater a lot more exciting, and that is Stefan from Aquature.
Hello, everyone. Can you hear me well?
We can hear you, Stefan.
Great, amazing. Okay, hello, everyone. Thanks for having me here. My name is Stefan Georg, and I'm one of the co-founders of Aquature. We're going to make clean fuel from liquid waste. And as you can imagine, it's quite an undertaking to make fuel from waste, so we need broad expertise. Next slide, please. In our co-founding team, we have expertise that is broadly distributed, both culturally but also professionally. I am our biotechnology expert with 6 years of research experience in our core technology, whereas Ahmed is our green energy expert with 10 years of experience in green energy at Halliburton and Technic FMC. And Jose is our wastewater expert with 8 years of experience in biogas and wastewater management at Severn Trent and Wessex Water. And together with our technical advisors who are pioneers in our core technology and our business advisors who are helping us with the commercial side of things, we are striving to shift the waste paradigm to energy recovery for our industrial partners. Next slide, please. We actually came to the same conclusion, all three separately and in parallel. And Jose was looking at this problem from a wastewater perspective. He saw that 2% of the energy consumption in the world goes into wastewater treatment at the moment, whereas 3% of the greenhouse gases are emitted in CO2 and NOx. And in this wastewater treatment process, 50% of the carbon in the wastewater goes into CO2, whereas the other 50% goes into sludge. That leads us to disposing sludge or recovering some of the energy that we invested initially. And in this case, that's only 30% that you can recover. And on top of that, there's also an economic issue where biogas subsidies had already phased out, which means that the wastewater treatment sector is looking for a new energy vehicle to convert from wastewater. And we think that is hydrogen. Next slide, please. Ahmed was looking at this challenge from an energy sector. So he was looking at how to decarbonize the energy sector most effectively, and he found that hydrogen could be a potential vehicle. But the current production methods are way too expensive. They're more than 2 pounds per kilogram of hydrogen. Whereas if we wanted to replace, for example, natural gas as a fossil fuel, we would need to get below 1 pound per kilogram of hydrogen. Next slide, please. At Aquature, we combine these two sectors and these two problems into one solution. We make hydrogen below 1 pound per kilogram of production costs by using wastewater as a biomass feedstock. And because of our dual revenue model, both from wastewater treatment and green chemicals production, we managed to be subsidy independent. And we combine these two opportunities in a technology that's called microbial electrolysis cells, which you can imagine as a combination of a bioreactor and an electrolysis cell. Next slide, please. So for our customers, they currently face the problem that they have highly concentrated wastewater that they cannot discharge to the sewer, but rather need to truck off to wastewater treatment facilities where they emit a lot of greenhouse gases, and it's very expensive for them. We aim to replace this current system with our shiny Aquature container system. And in this system, we use renewable energy to treat the wastewater in a modular and multi-step process. The first step of this process is where we feed the wastewater in our pre-treatment step, which is called the hydrolysis step, where we split up the wastewater into the gases and liquids. And then in our bio-assisted electrolysis step, we produce hydrogen from that wastewater and CO2. And the CO2 is then captured and led into our bio-assisted CO2 fixation process, where we produce carbon neutral fuels from that CO2. So this modular unit is actually very flexible, and we can very well adapt it to our customers' needs. We provide the following values for those customers as well. We capture 10 tons of CO2 per ton of hydrogen produced. We produce green hydrogen that is very cheap, and green chemicals as well. We're net energy positive and carbon negative, and our treatment system is 10 times faster than conventional treatment. Next slide, please. Thereby, we provide our customers with up to 40% cost savings downstream in their wastewater treatment, while at the same time upstream providing cost benefits and access to cheap green hydrogen and chemicals. Whereas AquaTure's revenue model is based on the service fee per cubic meter and the sales of green chemicals and green fuel. Next slide, please. So we have garnered attraction from several customers already, with TEAs in progress worth £4 million over 3 years in trial to pilot conversions. Next slide. And our market consists of the £25 billion market of wastewater treatment in the UK. Next slide. And the green chemicals market, which is another added £20 billion. Next slide, please. Our development timeline started this January, and we've already talked to customers. We are establishing our lab facility next month, and we're closing our pre-seed investment also thanks to TechX, which we're going to use to build our proof of concept and our pilot plant. And from 23 on, we're going to look for seed investment for full industrial scale. Next slide, please. So if you know anyone who wants to have their wastewater treated and produce green chemicals from that, feel free to contact us. Thank you very much.
Right on time. Thank you, Stefan. Right, our next pioneer is coming from Glasgow today to tell us all about her groundbreaking technology, which is an alternative to grout. Please welcome Jacqueline Morrison from Sedeco.
Hello. Next slide, please. So I'd like you to picture the scene. It's 2016 and we are absolutely delighted because our first patent had just been granted. So the idea was for an improved jacking system for jack-up barges. And with the patent granted, we thought, yes, this is it, we've made it. But what we'd actually made was a classic mistake of designing something that nobody wanted, because no matter how hard we tried, we just couldn't sell it. Next. So during this process, Scottish Enterprise had given us some money to make some funding to make a 3D model of this system. As a model was lying on the windowsill, gathering dust, I was beginning to panic because we were running out of money. But then this email arrived, and the email was from Scottish Power Renewables announcing the launch of an innovation competition. They were looking for alternatives to grout when installing offshore foundations. Now, not gonna lie, by that time, desperation had set in. And even today, I clearly remember looking at that dusty model and thinking, if I turned you sideways, would you hold up a turbine? And that sideways thought is what led us here today, because we entered that competition and we won. Next. When you look out to sea, you might notice some turbines are sitting on top of 3 or 4-legged yellow structures. The yellow structures are called jackets. When installing the jackets, you place the jacket inside the pile and you fill the gap between the pile and the jacket with grout. But grouting can be a challenge. It's time-consuming, it's expensive, and it's generally difficult to do, whereas our solution removes the need for grout entirely. If you think of a door wedge and the way it holds a door in place, you'll have an idea of how our solution works. In fact, you could say we wedge the jacket into place. And this is a challenge worth solving because offshore wind is a growing and global market. The UK has just announced new targets of 50 gigawatts by 2030, and that's 5 times our current capacity. So over the past 2 years, we've been gathering data and evidence and doing some computer modeling. So far, the data shows that our approach is quicker. We can save up to 50 days installation time, and our approach is cheaper. We can save up to £14 million in installation costs, and that's because there's less boats involved. And lastly, our approach is cleaner. We can save up to 40% of the CO2 equivalent emissions. Again, because there are less boats, but mostly because we've removed grout from the process, and grout is a source of embodied carbon. When talking to customers as part of customer discovery, this time saving generated a huge amount of interest. Because if your goal is to generate electricity, our solution allows you to achieve your goal sooner. Of course, there is a small catch. We're at technology readiness level 4, with 2 years of development still to go. But we're confident that the computer modeling shows that the system will work as designed, and we've started checking those results with small-scale testing at Strathclyde. So the team is myself. I'm an Innovate UK Women in Innovation Award winner. a Bayes energy entrepreneur, and now a TechX pioneer. And I work with Ian, a marine engineer. Because we are a small team, I've taken the funding that I've raised and I've used it to try and build a larger external team. Since January 2020, we've been working with Kent, the engineering firm, and the team includes Trevor, a technical authority on offshore foundations. We're also working with Strathclyde Uni, and we have 2 external advisors, Rob, who is the engineering manager for Codling Wind Park in Ireland, and Zoe, who is the strategy manager for wind developer Keybridge. Now, clearly, we won't bring this technology to market on our own, and that was never the plan. The plan has always been to work in collaboration with industry. And since you're here today, I'd ask, if you can think of anyone else that we should be speaking to, especially around field trials, please let me know. Because trust me, we've learned our lesson. The only way to build something that the industry wants to buy is to ask for your feedback along the way. So that's been our journey, except I have one last wee thing to tell you. Sadico has always been Ian and Jacqueline, and I know some of you might find this really hard to believe, but I am a terrible, terrible backseat driver, and it's time for a change. Next. Going forward, we will be Napkin Innovation, still with Ian and exactly the same team, but now it's my turn to drive. So I'll be taking us forward, and I'll be delivering on our vision of supporting the deployment of offshore wind on a global scale. Thank you.
There was a twist at the end. Nobody saw that coming. Thanks, Jacqueline. Just a shout out to our virtual audience. Remember, this is an interactive session. So post your questions, please, on Menti using the Menti code that popped on your screen. Right. Have you ever wondered how great it would be to have 5G at sea? I can't even get 4G in Union Street at best of times. However, our next pioneer has been working on that. Please give a warm welcome to James Thomas, CEO of Jet Engineering.
Hi there. Thank you everyone for taking the chance to let me present to you today. I so much imposter syndrome right now. It's unbelievable. Like following those pioneers, not sure how I'm going to even stand here. We built a floating 5G network. So this is our buoy that floated 2 weeks ago. We're going to do some press on this in a couple of weeks, and it's a floating base station. So we can pop up mobile phone far cheaper, more sustainably than possible at the moment without a fiber optic cable for installation, massively changing the offshore experience. Next slide, please. I think I was going to go and put the meme voice here. So there's the, do you know that, yes, that's me thing that's like this little meme. There's a voice note that I can't have, but this is where it all started. So I was sailing in this little boat here. 2 of us went to Southern Ireland and back, and we had no engine, no comms, because it all went wrong. Just genuinely, it all went wrong. Next slide, please. So this is middle of the Irish Sea, small boat, no comms, no sleep for 4 days, 5 hours. We had dolphins swimming around the bow at night, and they have these phosphor trails. Don't know if anyone's ever seen that, but it feels like you're in Tron the movie, especially when you haven't slept for that long. There's just a bit of hallucinations going on. But with comms, you would have gone, actually, what could we have done? How could we have done this so much better? Next slide, please. Because what we recognized actually, it wasn't just us that had no comms. It's so many other people that have the same problem of this lack of communication in that sector. So offshore wind, they've got no comms whilst they're doing the installation, servicing, and commissioning phase. That's a huge problem because you've got people with living at sea without being able to tell their families about what's going on in their worlds. Can you imagine having your kids on land, not knowing if they were ill and having a voice chat, all those emotional things that can't happen, let alone the operational performance piece, the huge market that sits behind that, the financials drive that. And then everyone in this room's got some great technology that's going to rely on some comms to work, drones, the fantastic presentation to start us with for Idologic here, and how that they're flying over the water, right? Wouldn't it be great if they had more bandwidth and better connectivity whilst they're doing that, rather than relying on really rather expensive SATCOMs? Again, there's defense applications, security applications, safety applications, autonomy. How do we regulate autonomy at sea without connectivity? There's just so many challenges without comms. Next slide, please. So this is kind of where we started. We've done an animation. I got someone on the Kickstart scheme into the business, and he did this rather than paying for it, because I thought that was far better to build the team skills. It's really gone badly. But we built buoys that had weather stations on them. And that was our first UE, like a floating mobile phone, to try and understand what a floating mobile phone could give us in terms of bandwidth over 5G. We then deployed it with underwater cameras. So we've got 2 real-time 4K cameras streaming over 5G off a buoy. That's showing like the 300 megabit per second data rates of what's now possible on the platform. And then we've started to build these base stations. You saw one of these in real life. They're 4.6 meters tall currently and weigh over a ton. And that's kind of cool to have actually built real hardware, real tech, something actually physically that's going to do something. And we've got one of these now that's at sea. Again, sorry for the rendering. I really need to help them some more, I think. But we're now trying to work through how do we finance and fund a network at sea? Who are the key targets for that? What are the anchor tenants to make that possible? And then who are the other people that are going to benefit from when we do this? What data can we harvest from those platforms? If we have a wind map of the whole of the North Sea, there's so many applications here that could benefit from that. If we have a wave map, helicopters can fly a lot easier out to your platforms. Did you know that 6-meter wave thing where you're not allowed to fly a helicopter? We could say, go around the southern bit, you can actually still get there and do your operation for the day. The crew welfare, all the applications. So we're gonna scale this up and roll this out. Next slide, please. We're gonna cut the end of that. So our business model is about this anchor tenancy against the capital cost that I'll then raise the asset finance against and then roll out a network. I think the really cool thing is we can put this array here, that could have like 36 million gigabytes of data across it per year. And when we talk about that at £5 a gigabyte, which is a fraction of Satcoms, Satcoms is about £600 a gigabyte some people are paying. That's a huge advantage. Yeah, there's TampNet out there in the middle, but we want to be the connection between the shore and what's out there whilst they're building those installations, whilst all this is going on. Next slide, please. So Minister Matt Warman came down, had a look at what we did. At the middle of the lockdown, bit of fizz on the boat, can't tell anyone that, but it was great fun launching our network when we first got something to actually go to sea. And that was when we formed the business in 2021, 2020. We then got the grant funding and the proof of concept together, which is where we got that base station floating. We've got some commercial agreements in the offshore wind and the security sectors. And we've got a £200 million pipeline now that we're going to address over the next 4 years. At the moment, we're looking at how we finance the network operation, how that rollout is, who the partner needs to be. Do we get someone like an O2, a Telefonica to run it for us, and we just prime into them? How does that structure commercially? And that's where we're going now. We're looking at debt finance growth as well. So we are raising. I think most of the round is now secured. Next slide, please. I've got about 2. Next slide, please. That's not a good one. I'd like to go to the team if that's okay. Next slide. We're faster, more secure, better data rates, but the team, we couldn't be here without the team. Vicky.
Thank you so much, James. Thank you. If there was one pioneer I knew I would have had to stop, that's James. He's definitely getting the award of the most talkative pioneer. No. Right, it's time now for our Q&A session. So we're going to bring the chairs. And I would like to ask on stage all the pioneers who have been presenting on this second part. So Jacqueline, James, where is everybody? John and Einar. Here, we've got everyone. John, if you can sit here actually next to your fellow pioneers, I will sit here. Right, who wants to open the session from the floor? Colette.
This is just to give you all time to think of your questions. I'm going to start with John on Zemfield. I was curious about the size. So you talked about 3 cells going up to 30 cells for 1 gigawatt. For me, visually, I can't imagine what volume or size that is on a boat. And so how does it compare with our existing kind of propulsion system? And then the space required also in the energy efficiency to support it. So ammonia versus diesel. I mean, is this a big change to the overall how we operate a boat, or is this something relatively simple to retrofit?
Yeah, no, we've been lucky enough to be on some boats recently and looking at them. So let's say 100 kilowatts, which would be building it. That's about the size of an American freezer. So an APU is about the size of a Keller gas cylinder. And the ammonia to fuel that would be also about the size of a Keller gas cylinder. So that's one of the things we think we're in good shape on. So, but yeah, key point. It's not, the energy densities are pretty good.
Thank you, John. There is a question here online, and that is for Stefan from Aquature. So I know that you have been mentioning about biogas being not viable anymore. Now, how do you position your technology and how can you combine it with other technologies that are used in the wastewater industry, such as waste heat recovery? Is that an option?
Yeah, so our technology is very, very flexible. So we already integrate a lot of wastewater treatment technologies in our own process. For example, you can also couple it with other CO2 upgrading technologies or with other pretreatments. Our technology is very flexible in that way. So for sure, you can couple it also with other technologies. Absolutely.
Thank you, Stefan. Any questions from the floor? Don't be shy. Hey, Jerome, thank you.
Thanks. Jeroen, still Equinor Ventures. I have a question for Jim, and that's your concept. It was very convincing, your pitch, and I was just wondering, how are you going to convince the industry to completely revolutionize the way they build the turbines? So I can imagine that can be a bit of a challenge.
Jim, you're on mute. Can you check your microphone?
Sorry. Yes, thanks, Jeroen. And I was saying, I thought you could tell us, but no, seriously, we have a very aggressive technology development and validation approach. And so we have to pass through the, DNV kind of certification and various kinds of meeting standards and proving that our system will work. And I think in the end, it's going to have to come down to that we demonstrate that it works and we show big cost savings. And I don't really have another answer unless somebody wants to take maybe a kind of a gamble on what's unknown because the promise is so great.
Thank you, Jim. We've got a question here for Einar. Einar, UpCatalyst is based in Estonia. What was the attraction for an Estonian company to come participate in a UK-based program?
Good question. Actually, just to bring some personal point to the game. So I actually studied here in Aberdeen, at the University of Aberdeen. I did my environmental chemistry degree here. And of course, Aberdeen is an energy center in Scotland and also in Europe in general. So I believe changing from the fossil fuels into sustainable technologies is a great way to go forward. And Aberdeen is a great place to make it all happen.
Thank you, Einar. Oh, Dushyant here. He's got a question on the floor.
A question for Jacqueline, if I may. So thanks for taking us through your story, fascinating to see. Now that you've taken the steering wheel from the back seat, what are you going to do differently?
Do it a lot quicker. Much faster decision making and do it the way I want it to be done. There are hoops that we sometimes have to jump through, so I want to jump through them quicker. Thank you.
And here is a question for all the pioneers, actually. You've all been, well, you're all running startups. How have you been able to combine your startup life with attending full-time a program for 15 weeks? Who wants to take it first?
I'm fortunate my partner's a lawyer, so I don't really see her, and she understands what that's like. She doesn't really see me either until sort of about Sunday afternoon when we sort of leave the desk eventually. But I think the benefits outweigh anything right now with the accelerator program. Those first few weeks, though, I think everyone probably sitting here goes, those first few weeks where it's just suddenly 40 hours a week gets added to your life. It's just so hard, but so worthwhile at the end of that day.
I would add, if you want to come up here, you'll see the red eyeballs. So I think that probably tells you everything.
it's definitely the team. Without the team, it would not have been possible. And we are really grateful also to the organizing team of TechX. It has been amazing experience, great journey. They have done really amazing job. Thank you very much.
Just the same, the team was really, I've been able to step up recently, but the team, sorry, took the initial hit.
Thank you. Oh, sorry, of course, sorry. Jim.
Yeah. Yes, thanks. Look, I wanted to say also it's the team. We have a fantastic CEO, that's Britta, and other members of the team doing all the hard work for the company while I'm getting up at 3 a.m. So thanks to them.
And Stefan? You're on mute, Stefan.
Can you hear me now?
Yes.
Hello? Yeah. So from our side, it was very intense as well. So I completely agree with James there. But I also agree very much it was completely worth it. So I think the TechX program has really brought us forward as a company. So there was also quite some overlap between our activities and the TechX activities. So that was really great. Thank you very much.
Thank you. Thanks to all of you. I think if nobody, oh, Colette.
Having listened today, I was struck by the RepAir presentation earlier with, that's going to give you a CO2 stream, whether Up Catalyst had talked to RepAir, like whether you'd use this opportunity and whether their outlet stream would actually be a good input stream to what you're doing.
Absolutely. There's great synergy between all the pioneers, with all the startups. Many things can be done together. We are, for the sustainable world, we need cooperation. We are all out for the same goal, and it needs to be done all together. Otherwise, it's not possible. So absolutely. And this collaboration with other pioneers and startups, absolutely. This is the way to go forward.
Great, thank you.
Law, we got a question here.
Oh, sorry.
Yep, my name's Steve Aiken from Intelligent Plants. We're a company in Aberdeen as well. Einar, I had a question for you because I was quite surprised at how intensive the process was to create the carbon for carbon nanotubes and stuff like that. I just assumed they dug up coal. What's the existing process that people go through to get that you're doing better?
Good question. So there are very many different forms of carbon. Carbon in the form of CO2, carbon in the form of diamond, carbon in the form of graphite, which can be either mined or synthesized from petrochemical coke, and also carbon nanotubes. The main method to synthesize carbon nanotubes is with chemical vapor deposition method, and also the numbers I compared with, this was with the chemical vapor deposition method. This is the commercial standard being used how to produce carbon nanotubes at the moment, but our game-changing technology will tackle it to the good. So for our technology, the carbon comes directly from CO2. So this, basically we pump CO2 through our molten salt technology and electrochemically split the molecule into pure carbon and oxygen.
And Law, we got another question here.
Hello, my name is Arne Gutner from Equinor. I have a question to Jacqueline, and the growth connection intrigued me in a way, and you spoke to the installation and the opportunities of saving costs there. One of the challenges with ground connection is the durability and dynamic and vibrations and the uptake of which. So I was wondering, how are you convincing me that your solution is has a durability?
So one of the companies that we work for or work with is Kent Engineering. Kent used to be Atkins. So they form part of our technical team, and they are doing a lot of the dynamic testing and the loading, and they're looking at different types of fatigue. And we have a testing philosophy document and a testing plan in place. And with the funding that we secured from TechX, we'll be able to put some of that testing into play over the next 6 to 9 months. Thank you.
Thank you. There is a question online here for Jim. You mentioned new markets that don't have access to wind energy yet. Could you please expand on that, Jim?
Yes. Can you hear me?
Yes.
Okay, so today's offshore wind farms are very infrastructure intensive. You need to have special ports, special, deep hardened quays. You need big cranes, big ships. So it's really not and you have to have large wind farms to support the port upgrades and the maintenance facilities. So it's kind of a first world country high infrastructure way to produce electricity. So many parts of the world, the ports may not be so good, the populations may be smaller. Also, there's a question of deeper water, which conventional turbines can't really operate in. So we're proposing that we make not only a utility scale turbine that's somewhere towards 10 megawatts, but also an island model, maybe 500 kilowatts that could be shipped in a container. A village, coastal village, could install 2 or 3, maintain it themselves, no port, and thereby benefit from offshore wind if they're in a location which doesn't support the onshore renewables because too much population or not enough sun.
Thank you, Jim. I think we have time for maybe one more question. Does anyone have a question on the floor? Yes?
Yeah, it's for ZAM Fuels. Just interested to know what your reasoning behind ammonia was for the fuel cell.
Sorry, could you also please say your name and who you work for?
Lewis Harper at the NZTC.
Thank you. Ammonia it's very hard to store hydrogen. It's got very good energy density, but when you start putting it into a vessel, there's a lot of weight and a lot of volume losses. And actually, ammonia, any sort of liquid form of hydrogen is a much better carrier. So diesel would be quite good, but ammonia is so tractable. It's as close to being reversible as you might get. So it's a really good energy dense source. And 20% of the chemicals moved around the world at the moment are ammonia. So actually, I would say the regulations for handling ammonia are better defined than hydrogen. So the hydrogen is always worrying about what the next rules are going to be. But with ammonia, we already know how to bulk handle it and how to deliver it. Even though there's lots of sensitivities and worries about it, the actual rules are there already, and we know how to do it. Thank you.
Thank you. There's maybe one last question from the virtual judges, and that's for James. You've mentioned a few different industries that could benefit from your technology. Going forward, which is a sector that you think will beneficiate the most from it?
I think it's going to help drive the offshore wind industry to quicker installations, servicing and commissioning. I think that's the main clear target that we're looking at because they're spending 3 years at sea with 300 people to install each wind farm with very limited comms currently. 8 megabits per second is the max sort of people are generally getting, but some are getting 40, and that's the best case. So when we're looking at actually providing real-time floating 5G and hundreds of megabits per second, if we can help that energy transition, that's a massive win, not only for sort of the industry, the welfare, the crew, but actually the UK and society as a whole. I think that's where we're looking to try and impact most. Thank you.
Perfect, thank you. And I think that's all the time we had for. So thank you so much to the 6 of you. And I will now let Mark come for closing remarks.
Thank you, Laure. Wow, what a morning it's been. We've heard from 12 outstanding companies. They've all pitched to us, and I would first like to give a very big round of applause to all of those, please. It's a fantastic achievement to have come to the end of the program, and listening to you has been a real inspiration. So well done, and we look forward to monitoring your amazing progress going forward and the tons of carbon you're going to be saving. So fantastic achievement. Well done. So how can you continue to support? Well, one of the things you can do is to keep in touch with our pioneers, and you can do that through our website. We have a brochure of these 12 fantastic companies on our website, and you can look at the pioneers up there. You can contact them. You can contact their TechX team. So do keep in touch. We'd love to hear from you, as would they. You can also, of course, come to graduation this afternoon. So graduation starts at 3:30 UK time this afternoon. And at graduation, you will find out the winner of a fantastic set of prizes and awards. So do join us for graduation later. We'd love to see you there. So that concludes the session. It's been a fantastic Demo Day 2022, and thank you so much for attending, and we look forward to seeing you very soon. Thank you.